A way to generalize what we're talking about is to say that we're talking about the nth root. And the nth root is just a general term. I could be talking about the cube root. I could be talking about the fourth root. I could be talking about the square root. Right? Nth root is just a general form of all of that. Now sometimes, when you're dealing with, any root, you will have a negative number inside the radicand. I want to talk specifically about negative numbers inside the radicand. You already know that the square root of a negative number, like -5, we would say that there's no solution at this point. Really, it's no real solution. The important thing to note is the index there is 2. We don't normally write it down, but the index is 2. Now here's kind of the big takeaway right now. For even index numbers, so if you're taking square roots or fourth roots or sixth roots or 128th roots, if the index is even and the radicand is negative, the answer is no real solution. But odd indexes like cube root and fifth root and 193rd root of negative numbers, those exist. For example, the cube root of -8 is -2. And that's because -2 cubed equals -8. That's the major takeaway from this video, is that even index numbers, there's no real solution to negative radicands, but odds there will be. Let's look at a couple. The cube root of -64. Well, -64 is -4 cubed. So the cube root of -64 is -4. But if we had the fourth root excuse me, of -16, this is no real solution. It's no real solution because the index is an even number and the radicand is a negative. That's always the case. There's no real solution. And the reason that is because 2 to the fourth is 16 and -2 to the fourth is also positive 16. There's no number that you can multiply an even number of times and get a negative number. Last one for this. What is the fifth root of -243? Well, hopefully you're starting to remember that 243 is 3 to the fifth. So -243 must be -3 to the fifth. And so the fifth root of that must be -3.